Hello viewers, welcome to Taxonomy Online Mathematics. It's been a while since we had our last tutorial, I think almost a month. That break was necessary because I was indisposed, but God being so good, my strength is back. And we are continuing from where we left up. So we will continue with topics by topics. Then we will take questions along the line, and better still, we will have time to have our live sections to interact. So today we'll be dealing with number bases. So with the SRS simply means that there are different number basis systems that we deal with when it comes to mathematics. The commonest that we are used to so far is the base 10 numeral, or better still the decimal numeral, which deal with the 1, 2, 3, 4, the counting numbers we know up there. Now we can see that the symbols that we make use of, when I mean symbol, I mean the digit, is just, you can see that these are the symbols that we make use of when they come to base 10 numeral. So we have sequential combinations of these numbers, as in 0, 0 give us a fair idea of what we are referring to, 0, 1, 02, 08, 09. Then if I also want to begin with 1, 1, 1, which we know is what 11, 1, 2, 12, 1, 7, 17, 7, 8, 78, 7, 9, in that order. We just combine them. We have not seen a single digit to represent 10. We are in base 10. I mean base 10. Base 10 numeral. There is no single digit, as we are saying here, representing 10. It means if I want to do calculations in base 10, these are the digits or the symbols I need to make use of by combining them any way necessary. But you have to know that how many are they? There are 10 digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 digits. So this also gives us fair idea that in any base that I'll be asked to do my calculations in, the number of digits will be equal to the number of base, or the name of the base. Better still, base 5. How many digits do I need in calculations base 5? I need 5 digits. So 1, 2, 3, 4, 5. So 5 itself will not be included as a symbol in base 5. If I want to calculate in base 2, for example, it means that I need 2 symbols or 2 digits, 0 and 1, meaning 2 itself will not be included in such calculations. That tells us that we cannot have base 1, because if I'm having base 1, I need only one symbol, and that symbol is going to be 0. So no matter how I compile zeros, it will still remain 0. So if I have 0, 0, 0, 0, 0, or doubling it, I have to add 1 to it to make it meaningful, or a different symbol. So in that case, there is no base 1, but base 2 can be reasonable, because I can have 0, 1, 0, 1. I can have 0, 0, 1, 1. You can see that, which in this case we call what? Binary numerals, which computer make use of in keeping data or processing data. Okay, so under base 10, in these combinations, if I have a number as in 27, if I want to take into consideration base 10, it means that I'm having 2 groups of 10. That's the meaning of the 2 combination. This is going to be 2 groups of 10 and a single. If I want to represent all these by, let's say, a peanut, let's say I have 27 peanuts, I can group them into 3 groups. Why 3 groups? It means that I can put 10 of the peanuts here, I can put 10 here, and put 7. So here I can say I have 2 groups of 4 tens. And this is just what? 7 units. We know units simply mean 7 ones. They are just dig 1, 1 up to 7. It's not up to where they can bundle. You know, when you are in basic school, we know to have a 10 bundle of a stick. If it is not up to 10, we don't have to bundle it. It is still become a singular. So we can call this. The same thing if I have 5 and 7. Let me change this digit to 6. It becomes 56. This also tells us that we are having 5 groups of 10 and 6 units or 6 ones. That is the idea. You want to build up that idea into various bases. Okay, so that will lead us into what we call the place value. It means in this case, I should be having 2 times 10 plus what? 7. 2, 10, 20, 20 plus 7, I have my 27. So I can also say that, okay, the place value of 2 is tens. The place value of 7 is unit or ones. So I can write this to be 10. Then I have what? Ones. But in trying to borrow the idea of indices, I can say that this can be 1 and this can be 10 raised to the power what? 0. 10 raised to the power 0 give us 1, as we know the 1 as a unit. 10 raised to the power 1 give us what? 10. So the place value here is going to be 10 and this is going to be ones if I deduce that. What if I have 6, 4, 3? What do you think the place values in terms of indices will be? 10 times what? 10. Let's say if I have this, that's 10 groups of 10 as a place value, but there are 6 of them. So I have this. This is also going to be 4 groups of 4, 10, and this become unit. So better still, I have 640 plus 3, 643. So going back into indices, this gives me 10 exponent 2, this gives me 10 exponent 1, and this gives me 10 exponent what? 0, as in decreasing order. You can say 2, 1, 0. The next will be negative. Alright, so this is what we can deduce in number base 10. So simply means that if I move away from base 10, any other number I'll write must also have its indications of a place value. I will not be writing numbers in base 5 and be using 10 as a place value. I have to be using 5 as a place value. Simply put, if I have 25 and I leave it like this, I am trying to say that I'm having base 10. What tells me that this is going to be base 6, base 7, base 9, even base 5, if I can say that we don't have 5 as a symbol anyway. So I have to indicate the base this time around. The base has to be indicated. So let's say I indicate 8. I am telling anybody seeing this digit that this number is not the usual 25, but rather 25 in base 8. In base 8. So in base 8, what will be the place value? This means that there are 8 groups here. This is going to be 2 groups of 8. That is going to be 5 units. Still in base 5, in base 8. So I'll be having 2 groups of 8. Then this is going to be 5 what? Unit or 5 ones. If this is a group, then the unit of base in terms of indices could also be 8 and 8. But you see the sequence that from the right, the power always starts from 0. Because if I put 0 here, I'll be referring to 5 units. So any number raised to the power 0 give us what? 1. So that's ones. So this is going to be ones, as in 5 units. Then this take exponent of 1 from 0 to 1. This is 8. So the place value of 2 here in this digit is 8. I mean the place value, the position that it is holding is 8. If we continue further to say that I have 2, 4, 3 still in base 8, the place value, if this is going to be 8 exponent 0, 8 exponent 1, and 8 exponent 2, what will be the place value of 3? I'll only say what? Ones or unit. Ones or unit. Place value of 4 is going to be 8 in base 8. The value that 4 is holding is 8. Then let's come to this. The place value of 2 in this digit is going to be 64. Position, as we have for this, the place value of 6 is what? 100. Not 6 and 100. 100. The position that the 6 is holding is 100. The position that 4 is holding is what? 10. And this hold ones. So the position this is holding in ones, then the usual 10 is now 8. Then the usual 100 now become what? 64. So in any base at all, we can be able to deduce its place value, provided the base is indicated. Alright. Let's say I have base 5 and I'm asked to indicate the place value. We know that this is in base 5, so each of them has to be a position of what? 5. But we know for me to get this as ones, this is what? 5, one group of 5. Then this is going to be double group of that. So this is going to be power of 0, 1, and 2. So I'll call 3 to have a position of what? 1 or unit. This will be 5. This will be what? 25. So the place values of each of the digits now is clear, provided the number base is indicated. Alright. Addition of number bases. How are we going to do that? Let's begin with the usual base 10. Let's say I have 47 and I'm to add this. Don't forget that any number that is written without the base is base 10. That's a number we already know, the numerals, base 10 numerals. So if I'm adding this plus this, that is going to give me a group of what? 1, 10s, and what? 2. I'll be having 12. And it's going to be 10 groups, then 2 single. And you know that this position is standing in for a single position. So I put the 2 there. Then this is the position for what? 10. So this is 40. 40. So I still indicate my 10. That is how come we don't write a 0, but we indicate the 1 at the other side. So this is going to be that we carry the 1 to the other side, which is its usual place. The place value is what? The 10s digit. We add this to this and we have what? 6. So still we have 62. So you can see that our addition is in this form. What if I have this is in base 2? You should know that the symbols is going to be 0 and 1. So it can be combined in any order. This is just like a repeated number, but let's see how we can get answer to this. 1 plus 1 in this case is 2. 2 as a symbol is not used in base 2. So you find out how many groups of 2 can I get in 2. I can only get 1. Remember nothing. So that will mean that I will get 1 0. And this is the unit, and this is the word, the 2, the position 2, unit and 2. So I go down for the unit and send the position 2 to the top. So this plus this give us what? 3. 3 cannot be used as a symbol in base 2. So you find out how many groups of 2 can I get there. I can get 1 group and a remainder of 1. Do you see that? Or better still, divide 3 by 2. You will get 1 remainder what? 1, right? 1 remainder 1. Or subtract 2 from 3. You will get 1 remainder what? 1. And that is 11. So 1 remainder 1. 1 plus this will still give us 1. This will give us 2. And how many groups of 2 can we get there? We get 1, remainder 0. So we have 1, 0, indicate the base, then we are there. Same can be repeated for subtraction. Any other basis. This is the principle that we have to adopt. Alright, so going forward, what we are going to be dealing with is how we can change from one base to another base. Conversion between the bases. We can do subtractions. We said earlier on that if the number is written without a base, we are in base 10. We want to see how we can do this. This is 83 and this is what? 1818. Let me use the usual borrowing method. I know there are other methods or simple ways of subtraction this, but on the basis of this, let's just go with our usual borrowing. Since 8 is bigger than 3, there are 3 groups of 1s and there are 8 groups of 1s. We know we cannot subtract 8 from 3, so we need to borrow a digit from here. Now that digit we are borrowing is 1. If I take away 1 from here, I am left with 7. That is the idea. It is 1 that I am taking from 8. So I'll be remaining what? 8. Now by that number that I am borrowing, since I'm in base 10, is taken as what? 10. Are you with me? It's taken as what? 10. Is 10 that I am borrowing. Since I am left with 7, it means I am left with 70. This is 83. 80 plus 3. 3 is gone. Now I'll be having 70. If the 3 is still there, it will be 73. So I am borrowing 1, but in actual sense, in the value of it, it is 10 that I am borrowing. So 10 plus the 3 will now increase to 13. 10. In this case, we cannot put all the 2 digits here, so it become like this. 10 plus the 3, it becomes what? 13. So in fact, I'm borrowing 1, but I'm borrowing 10. So 10 plus this is 13. So now 13 minus this will now give us what? Our usual 5. So 5 is a digit in there, so I put my 5 out there. What am I left with? I am left with 7. 7 minus this give me what? 6. So 65 will be our answer in base 10. Alright, let's go further to have 45 and 23. Let's do this in base 6. Okay? Then base 6. This is going to be 5 minus 2 minus 3. Easy. So we have 2. So I'll have my 2 out there. 2 minus 4 minus 2 will also give us 2. So this is 22. But for me to indicate the base, it becomes 2 to base 6. You see, it's very easy. There's no borrowing. What happens if we turn the digit to become 43 and 25? Still in base 6. We want to still do the calculation in base 6. So let's see. We can say that this is ones. We can subtract 5 from 3. So we need to borrow. Right? So I'll be borrowing 1, the usual 1. So I'll be left with 3. If I borrow 1, that 1 I am borrowing is in the sense base 6. So what am I borrowing? Is it 1, 10, or 6? I am borrowing what? 6. Do you get the concept now? I am borrowing from here as the place value of this is 1s. The place value of this is what? 6. You remember? 43, move down, 6, 0, 6, 1. Place value is what? 1. And this is 6. So if I'm borrowing from this direction, I am borrowing 1s. If I'm borrowing from this digit, I am borrowing what? 6. So the 6 will be added to this 3 to give us what? 9. So now 9 is big enough for us to subtract 5 from. So I can get my answer as what? 4. Then 3 minus this, they are all in the same place value of 6 of 6. So no need to change their values. and that gave me 1 base 6. I believe you grab the concept that we are doing in borrowing. We borrow the base, whatever you are borrowing. Just as in addition, when we add the value, the excess value goes to its place value. That is the concept. I believe you have grabbed 1 or 2 things. The video may seem a bit long, a bit slow, but I think that we are able to work from the beginning to where we are. The next episode, we will take more examples to this effect and dealing with convection from one base to another. I will indulge you to subscribe to the channel, like and share. Leave a comment for us to get interactive. See you in the next episode. Bye-bye.